If you think surds are easy, try this question out. So this question was actually used in a TYS and also probably used in my EOI last year. So let's check it out. Given that 3 plus 2 root 5 is a root of the equation this, where a and b are both integers. Find a and b. So when you first see this question, a few things might come to your mind. First of all, what does it mean when it says this is a root of the equation? So another way of saying root is a solution. So what do I mean? Let's say if I have x squared plus 3x plus 2, this is equal to 0, right? And we can factorize it. So it's going to be x plus 2, x plus 1 equals 0, which means x equals to -1 or -2. This is what we've been doing every single time. And so the roots of this equation is just -1 or -2. Basically, it just means what makes this equation true. So that's a root. So basically, this 3 plus 2 root 5 is saying the x value. The x value of this makes this equation equal to 0. But that still doesn't really tell us much, right? So what if it's a solution? Now, there are two methods to this. One of this is my TYS method, the answer key, and one of it is my own method, which I came up with. And I'm going to show you both, just to make sure that you can have both the solutions. I'll show you my method first, which might be a bit more confusing. So, first thing I notice, I'm going to mark my method with red, and I'm going to mark the TYS method with blue, because different. So first I notice it's a quadratic equation. What does that mean? The quadratic formula would work, right? And we already know that one of the answer is 3 plus 2 root 5. So, I'm going to use it. So, we know that x is 3 plus 2 root 5 in this case. 3 plus 2 root 5, this is equal to -b. What's the b? It's the a. It's quite confusing, but just remember the b, when you're referring to b, you're referring to the b in this case. This is the standard quadratic equation. So the b is the coefficient of x. So the x is being multiplied by the b. So in this case, the x is being multiplied by the a. So a is our b. I hope that makes sense. So -a. Now, I initially wrote plus or minus, because that's what the quadratic formula is, right? -b plus or minus. But you don't need to. You know why? Because all you need is actually a plus. Because this is positive. If I have a square root of something, it can't be negative, because square root of anything can never be negative. So this is positive, this is also positive, so you just need to put a plus. Plus b squared, a squared, minus 4ab, this is a 1, 4 times 1 is 4, times the b, all over 2a, 2. So then I tried to simplify things. I'm going to multiply everyone by 2 so that this fraction goes away. This will become 6 plus 4 root 5 equals to, then just this whole thing without the fraction. -a plus square root of a squared minus 4b. And then, okay, so then you might be thinking, are you crazy? You just made it even more insane because there's two unknowns, but you don't have simultaneous equations. How are you going to do this? Well, at first, I thought, okay, I can sub in this into the x. So I can sub in this x equals to this into here and get a and b and try to solve simultaneous equations. I will let you try that on your own if that works. But that is not what I did. So eventually I realized it's quite simple actually, because you can compare the two sides since they're equal, right? So what I did is this -a, this is the part without the square root, and the part without the square root is 6, which means -a equals to 6. So divide by -1 on both sides, a equals to -6. We're done. But when you find b as well, because this is a square root and this is a square root, so we can compare with that. But you can't directly say that. What you need to do is, because everything is inside the square root, we have to convert this so that every number is in the square root. And that's actually quite easy. 4 square root 5. We know that we know that 4 squared is 16. So this is just equal to 16 times 5, which is 80. So by comparison, it would be best if you write down by comparison, otherwise the examiner might want to know how you get that. This a squared minus 44b equals to 80. You don't need to put the square root because even if you do, you just square both sides anyway. We know our a is negative 6, so a squared is 36 and this is 80. Then negative 4b is 44 and our b is just negative 11 and we're done. So actually this is not that bad. It's just that you might need to understand. So this is actually a good point where I say it doesn't mean that, oh, surds are just surds. They might test you on shapes. And quadratic equations, they might not just test you on discriminant, inequalities. They might actually combine the concepts together, which is a thing that has been happening more because they don't want you to just memorize the content of that chapter and let it be on its own. They want you to actually combine the knowledge from both chapters and learn it like that. So this is my method. I'll show you the TYS method next. Okay, so the TYS method is, well, kind of what I wanted to do. They see x equals to this, so they just sub in. So if I just replace all of the x with 3 plus 2 root 5, you get this. So that you have a 3 plus 2 root 5 plus b equal to 0. Then I'm going to expand everything out. So this will be 9 plus 3 times 2 is 6. 6 times 2 is 12. This is, by the way, from our, if you don't know, the special identity a plus b bracket square. This will be a squared plus 2ab plus b squared. So 2, then a, then a b. And then plus this square, which is 20. Yes. Plus, just distribute the a. Plus 3a plus 2a square root 5 plus b is equal to 0. It looks messy, I know, but we're going to clean things up so there's no need to worry. 20 plus 9 is 29, so it's 29 plus 3a. Then we combine everything, then plus b, sorry. This is actually one part. This is important for later. Then next, we just combine the square root, so this will be square root of 5 times, this is 12 plus 2a. So this is 12 plus 2a, and this is equal to 0. So this is where it gets a little bit tricky. This is equal to 0, which means that this is 0 because this, like, we combine them together, right? So there's just actually 2 items you plus together. What 2 items together can get 0? Well, you can argue like negative 5 and 5 or whatever. But I'll take the easiest case out. What if it's just 0 plus 0? You get a 0, right? So I'm gonna set this equal to 0, set this equal to 0. But actually I won't because, well, this is way easier to do. Because there's only one unknown. If you were to do that, don't do that. So I'm going to just set, and I don't need to include the square root of 5 because I can just divide both sides by square root of 5. So 12 plus 2a, this is equal to 0. So that means a, because you move the 12 to this side, get negative 12 divided by 2 is negative 6. Yeah, and if you sub this back in here, 29 plus 3 times negative 6 is negative 18. Plus b, you get 0. Also, because this is 0, this is 0. 29 minus 18 is 11. So that means b is equal to negative 11. So the answers are both the same, negative 6, negative 11. But the method of doing it is different. So there's more than one method to it. So yes, that is it for this video. Bye bye.